calculating z-scores in statistics. So not sure if you're going to get into this in grade 12, but if you do, at least you are going to get some opportunity to learn what it's about in this video. So whenever you study statistics, maybe at some point someone will ask you about these z-scores. So they're just basically kind of a number, okay, that we can compute that just tells you, how far off are you from your mean, okay, or at least how many standard deviations are you away from it. Okay, so I will try to give you an example on how to compute this, okay, and then I'll try to go over this definition just a little bit. Now, if you have a population, all right, so if you have your data set for your population, then z-scores are simply defined as, okay, they're defined, by the way, just for one individual data point, okay, so datum. So if you take one data point, you subtract the mean, okay, of the entire data set, okay, or your population, and then you divide by your standard deviation, okay, so that is for the population. Now for the sample, it's the same thing. The only thing is you might remember that to calculate your standard deviation for your sample is a little bit different than it is for your population. So if you forgot about standard deviation, I guess I'll put up a link up above there. You can rewatch it. I'll assume that you know how to do that. And of course, calculating the mean is something that you should understand. So I'm going to concentrate on the sample because it's very rare that we actually have a data set for the entire population. But as you can see from the definitions, they basically mean more or less the same thing. So again, your X is the data point you're interested in, okay, computing your z-score for. The mu, okay, which is the mean for your population, or simply X with the bar. So that is the mean of the sample. And then you have your standard deviation of the sample, which we sometimes designate just with a simple s. And if it's population, you would designate it with a sigma. Okay, and that's standard deviation. So there's the definition for it. So it's the square root of the summation, okay, of the squares of basically the deviation that you are away from your mean. And once you compute this, you're going to get one single number. And now what is that one single number? Okay, so that z-score, what does it mean? Well, if you can gauge through here, so notice what you're doing is you're just subtracting. So right here, okay, you're going to subtract your data point minus the mean. Now, if you do that and your data point is below the mean, so you're going to get a negative value out. And if your data point is above the mean, then you're going to get a positive value out. And really what you're doing is you're subtracting that, and then you're just dividing by the standard deviation. So you're just asking yourself, okay, how many standard deviations away am I from the mean? And if it's negative, then you're below it. Okay, so you're on the left-hand side of it. And if it's positive, then you're on the right-hand side of that mean. Okay, so that's what it would be. So here is kind of the summary. So z-score just tells us how far away is our datum, okay, or data point away from the mean. And in particular, it is how many standard deviations is it. Okay, so that's something that we can calculate. So I just want to give you an example. It's not super difficult. So I'm going to go back to this example. I talked about this example when I was talking about quartiles and percentiles. Okay, so quartiles, I'll put up a link up above there in case you're interested in that. You'll see that there. So here's 24 data. Okay, it's a set of 24 items or elements, and I've already arranged it from smallest to largest. All right, so we're going to make that assumption that it is arranged for us. If it's not, it doesn't really matter, okay, at least for the z-score. So now we do have to compute some z-score, all right? So in order to do this, we would have to find out what the mean is, and then we have to find out what the standard deviation is. So we have to know what the mean is, and we have to find out what the standard deviation. Again, I'm going to assume that this is from a sample and not a population. Okay, so I'm not going to compute this all the way throughout. Okay, I don't want to go through that burden. So I'm going to pop up Desmos here. I'll put it up on the right hand side, and then I'm going to work through it. So for instance, if you are using Desmos for this, you can certainly utilize it. So I'm going to put in all the values first. Okay, so I'll do that in fast forward fashion. So I'm going to create my array of values. So bear with me. All right, so those are my values. So that's my array. That's how you would input it into Desmos. You put it inside the brackets. Okay, and I called it A. All right, just so that I don't have to re-enter it all the time. So now if I want to know the mean, you can actually type out mean, open the bracket. I'm going to put in my array, and it calculates the mean for me. So that's going to be 3 bar. Okay, so that is repeating there. You can round if you like, so 3.83 or something like that. So that's my mean. Now my standard deviation. Okay, so the function. By the way, you do have the function. So on the right hand side, if you hit functions, you can look through them. You'll see statistics there. There's standard deviation, which is ST. I mean, I can just type it out. And then you can put your array in here, and it will compute the standard deviation for us. If you wanted to know, so this computes it for the sample. If you want to know it for a population, all you do is just put P in here. And that calculates it for a population. So the only difference is, as you can see there, the mean itself, and then the standard deviation is divided by capital N, which means all the elements, so the total number of elements. And for a sample, it's divided by n-1 for standard deviation purposes. Okay, so I am interested again. So here in just the sample. Okay, so here this is going to be 3, let's say 4. I'm going to round this. Okay, I'm not going to be keeping all those decimal values. So let's round that up there. So 3.41. All right, so now if I wanted to know a z-score for any of these, so if I'm going to get rid of decimals here. So if I wanted to know a z-score for one particular item, okay, so it doesn't matter what it was. Okay, so for instance, let's say I'm calculating it, what is the z-score? So here I'm just going to kind of make it up. Let's say if it was for the data value of number 1. Okay, so the z-score would be, okay, and you would say 1. So it's one of these, okay, any of those that we would have. Okay, we would subtract the mean, so 3.83, and then we would divide by the standard deviation, 3.41. Of course, I'm rounding this, and notice it's going to give us a negative value in here. So it's not very difficult to do. So 3.83, and then divided by 3.41, okay, equals, this is minus 0.8. All right, again, I'm going to round this to 3. Now, what does this mean? Well, number 1, the negative just simply means that you're on the left of the mean. Okay, so that's that. And this value, so if you take the magnitude of this, so that means, so you're about 83%, okay, of the standard deviation, okay, so of, okay, the standard deviation away. So that z-score of negative 0.83 just simply tells you that that data point is 83% away from the 83% of standard deviation, okay, away from the mean. So that's all that it means. And if we took one of the positive values, let's say if I take the last one, like 15, so I would take 15 minus 3.83 divided by, so again, 3.41. So this is going to give us a positive value of some kind. Maybe let me do it all in one. So 15 minus 3.83 in brackets divided by 3.41, standard deviation, and it's 3.275 and so on. I'll just round it again. Okay, so to about that. So this now is positive, and this would mean it's 325% 28% of the standard deviation, or 3 standard deviations away, okay, plus this extra little, 28%, okay, of a standard deviation. And now this is to the right because it is positive. But if you're looking at it when the data set is very small like this, it has 24 values, then it's very easy to see, right, where the mean is and then how many standard deviations away am I. Okay, so that data point or that datum would be. And you can calculate this z-score for any of these data points, okay, if you wanted to. So that is pretty much it. That is what a z-score computation is. So not very difficult to do, especially once you are familiar with calculating the mean and then calculating the standard deviation. To be honest with you, the biggest headache would be that. Once you have those two values, the mean and the standard deviation, calculating a z-score, it shouldn't be too complicated. And please remember that all it does is it tells you how many standard deviations are you away from the mean, okay? So this is from the mean. So that is really what that z-score is, which is kind of useful to be able to know. All right, so thanks for watching, and we will see you in a future video, okay? Bye, everybody. Cheers.